In this video, I'll be working through the question you see on the screen here from the 2025 Leaving Cert Higher Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. Okay, I really like question 9 because it's a quite important question to learn about how statistics use in and around testing positive and negative for certain things. In this question, they talk about diabetes and they give us some numbers. They tell us the whole population, 6.7% of people have diabetes. And they tell us about a test. It has 95% accuracy, it says. That's an important thing to know for future. 95% of people who have diabetes test positive. That's good. But 7.8% of people who do not have diabetes also test positive. And that's really the setup of the question. They then give us this tree diagram and want us to fill all the numbers in. And this is going to tell us pretty much everything we need to know about this situation. For example, there's the population and how many have diabetes is 6.7%, or in decimal place 0.067, and so on. We just need to fill all these numbers in. They tell us to use 4 decimal places. First one I'll do is, if 6.7% of the population have diabetes, how many don't? It's often just 1 minus in probability. So take this away from 1, or take 6.7% away from 100%. And let me start filling in some of these numbers from my notes. So the population who doesn't have diabetes would be 93.3%, or 0.933. Now next up, they told us if you have diabetes and you take this test, you are 99% likely to test positive. So that's where we get that. That means you're 1%, 0.01% chance to test negative. They also told us, they filled it in for us as well, that you're 7.8% chance to test positive if you don't have it. That means the opposite to this would be 92.2, 0.922. If you don't have it, you'll test negative. Now the final numbers are the important ones, because these don't show anything too strange yet. But these final numbers start to show something strange. They've put in the first one for you just to help you out. That's 99% multiplied by 6.7%. You'll get 0.0663 or 6.63%. Now that's interesting. Well, I'll wait till I fill the rest in to point out why that's interesting. Next, this number multiplied with this one. So the chances you have diabetes but you test negative, that's a very small number, and that's good. 0.0007, that's the 4 decimal places. The chances you don't have diabetes and test positive, that's a bad one, but still there's a 7% chance of that happening. And the chance you don't have it and you test negative, which is the most likely one, that's a 86.02% chance. Let me talk about each of these. If you have diabetes and you take a test, or take a COVID if you want to make it more real for you. If you have diabetes and you take a test, you want it to be positive. You want it to tell you when you have it. You don't want it to be wrong. So you want this number to be big. Certainly you want this number to be close to this number, and that's what it is. You don't want anyone, this is the number, I think this is the most important number. You don't want anyone that has diabetes to take a test and for that test to tell them it's negative. So you want this number to be as small as possible. This is 0.07%, a very small number. It's very unlikely you'll get negative if you don't have it. And the bad news is, but something that you're willing to accept, is if someone doesn't have diabetes and they take the test, they might get told they do. That's fine, because the doctor, the first thing they'll do is, here, take another test. And if you take 2 in a row, it's very unlikely this will happen. Take a third one. We'll take 3 or 4. And think of COVID. If you do not have COVID and you test positive, worst thing that happens is you stay home for a couple of days, you feel fine. But imagine how bad it would be if you had COVID and you tested negative. You'd go out, you infect loads of people. You want this number to be small. Sorry, that's my rant over. That's the answer to part 1 and 2. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, for part 3, we're going to use these numbers here to find out the probability of a person that's picked at random that they test positive for diabetes. So of these 4, these are the 4 probabilities. They should add up to 1, by the way. Which of these tested positive? It's this person, these people, 0.0663 plus this one here, 0.0728. What's the total number there? Add them together and we get 0.1379. Something I'll point out that we'll see again in the next part. This number is bigger than this one. So more people tested positive that don't have diabetes. It's a very interesting number. So whenever you see stats of how many people test positive or something, it might not be indicative of how many people actually have it. But as I said earlier, there's a reason why we don't care so much about this getting high once this number is low. Okay, so this is the answer to part 3, the probability that someone tests positive for diabetes. Part 4 then asks, the person picked at random does test positive for diabetes. Find out the probability that they actually have diabetes. So we have people that pick, that tested positive. What's the chances they actually have it? So let's work that out. The people who actually have diabetes are these people here. That's 0.0663. And the total number of people we're picking from now isn't the whole population. It's everyone that tested positive. These are the ones that have it, and the total ones are 0.1379. And if we put that together, we get a probability of 0.4808. That means there's a 48% chance. If you test positive for diabetes with this test situation, there's actually a slightly less than 50% chance you have it. So the first thing you should do if you test positive for things like this, well, talk to your doctor. But I'm guessing the doctor, one of the first things they do is they just test you again in a new situation. And the chances of this happening twice probably goes down significantly. And then they might do it again and again and so on. Okay, in part B, they talk about 5 people being picked at random and whether they have or don't have diabetes. So we have the number from previous, they tell us again, 6.7%. They want us to work out the probability that 2 or more of those 5 people have diabetes. This is a very interesting question because there's 2 ways to do it, a long way and a short way. Both are fine. The only issue is if they had have asked 2 or more out of 60 people, then there's a really long way and the same length short way. So let me do both ways here. I'll do it the slightly longer way first that I think some students might have done. So what's the probability of 2 or more testing positive? Well, I have to do a question 4 times to do that. I need to find out what's the probability of 5 people testing positive for diabetes. And that would be 0.067 times 0.067 and so on. 5 of these, or put that another way, 0.067 to the power of 5. That's the probability of all 5 testing positive. I need to work that out, and add that, I need to work out the probability of 4 people testing positive. That's 0.67 to the power of 4, them testing positive, and 1 person testing negative. That's 6%, so 93.3. So 1 person testing negative. Except there's an issue here. 4 people test positive, 1 test negative. How many different ways can this happen? The first 4 people could be positive and the last person negative. Or maybe the first person is negative, last 4 positive. Maybe the second person negative, third person negative, fourth person. There's 5 different ways this can happen. So I have to multiply that by 5. And I get whatever I get here. I won't. Oh, I have a. I think I wrote it down here somewhere. Yeah, this is a very small number. It comes out as 0 basically. It says it's like 6 zeros, and they only want 4 decimal places. So that's basically 0. This number here comes out again as actually no. This one comes out just barely at a 1. If you round it off to 4. And next one, what's the probability of 3 people testing positive? 0.067. This is the long way, remember? 0.933. There's 2 people positive, 2 negative. There's 10 ways this could happen. It's 5 choose 2. Or 5 choose 3 if you'd rather the same number. There's 3. These 3 people out of 5. How many different orders could it be? It's 10 anyway. And this comes out as 0.0026. And lastly, if 2 people test positive, 0.067, there's 2 of them, that means 3 must test negative. There's 3 of them, and there's 10 different ways that can happen as well, because it's 5 choose 2. And this all comes out as 0.0364. 5. Oh, I haven't rounded that one off. Let's see. That should be a 5 there. Okay, the answer to this question is all of these added together, and I get 0.0392. Okay, I promised you a shorter way. It's only slightly shorter though, but it's very useful to know in maths. Always be thinking in maths and probability, is it easier to do the opposite and then take away from 1? Or take away from 100% or something like that. In this case, we worked out the probability 5 people tested positive, or 4, or 3, or 2, because they said 2 or more. What if we worked out the probability 0 did, or 1 did? Because all of those numbers should add up. That's all possibilities in the world. They should all add up to 1. So if you had worked out the probability that no people test positive, that's 0.933 to the power of 5, and that's equal to 0.7069 I think 7 flat. Probability 1 person tested positive would be 0.067 multiplied by 0.933 to the power of 4. Oh sorry, and there's 5 different ways that could happen. And that would have equaled 0.25385, which all equals 0.9608. These are not the same number, but if you take 1 away from this, or take this away from 1, you will get, let's see, 1 minus this, it equals the same answer, 0.0392. That's a lot shorter than that. It's actually half the length of that. And indeed, if they ask, which they'd be very mean to do, but if they asked for, say, out of 10 people, 2 or more out, or 3 or more out of 10 people, you could see them do that. You'd either have to do 8 one way or 3 the other. So it might be useful to know this method. Now, before we do part C and D, I must warn you, I'm not the best with combinations, so definitely keep an eye out for any mistakes here. In part C, they tell us 20 people take place in a clinical trial. 10 of them are picked for group A and 10 for group B. How many different combinations are there? Thankfully, our calculator, we have a formula for it. We have a great formula for this. There's 20 people, you're going to pick 10 of them in group A. You don't even have to pick the rest. They just get, once you pick the first 10, they're gone. So this all comes down to 20 choose 10. There's a button in your calculator for this. So you put that in and you'll get 184,756. A hell of a lot of ways to pick 10 people out of those 20. Okay, in part 2 then, the 10 people are picked. They've set that in stone. 10 people have been picked out as 20 to go into group A, and obviously therefore 10 are in group B. How many different sets of 10 pairs can be made? Got to be careful there. I'm guessing a lot of students might have said 10 times 10, 100. There's 100 different pairs there could be. Everyone in group A could be with anyone in group B. So the first person could be with 10 different people. Second person could be with 10 different people. That's fine. There is only 100 different pairs. But that's not the answer they're looking for. They're looking for sets of pairs. So a set would be, in one set would be these two people, then these two. So this is one, there, and there's 10 of these. How many different ones of these could there be? And that's where we get a massive number. Okay, how are we going to do this? We're going to think of the first person as picking someone from group B. They're not really picking, someone else is doing the picking. But the first person here is going to choose their next person. It doesn't really matter the order of the first person, so they don't really get a number. That first person is going to have a choice of 10 different people. So the person we take from group A, doesn't really matter who, they're going to have a choice of 10 different people. The next person from group A, they'll be set. These two people will be set. They're going to have a choice of 9 people to pick from. The next person is going to have a choice of 8, and so on. This is going to go down 3, 2, 1. They'll have one choice at the end. This is a factorial. You don't have to put all this in your calculator. There's a button in your calculator, factorial, that'll do it for you. It's a pretty massive number. It is, there it is there, 3,628,800 different sets of these 10 groups. So I would have had to draw this block 3.5 million times. So that's the answer to part 2. Now in part D we have a problem. I do not have the marking scheme, so I do not know the correct answer, and I do not know how to do part D, at least how I read it. I think I may have just read it wrong, so I'm going to try and explain what I think the answer is, but I'll also point out where I think I might be going wrong, and maybe someone out there can help me. So in part D it's very similar to part C, in that there's a different clinical trial. There's 24 people and they're split into 2 groups of 8 and 16. So we could have 24 choose 8, and that might, I don't think that's important because I don't really know how to deal with that. That would give us a number. I have it here somewhere. Actually no, I don't even have it there somewhere. So that would give us a large possibilities of these 2 sets. The question goes on then to tell you that everyone in group A, or X and Y in this case, everyone in group X is paired with 2 people from group Y. So there's 8 in the first, 16 in the second. And they want to find how many different pairs of sets, just like in the previous part. There it is. I think we need to combine these 2 methods, but then we need to cancel something out, and I don't know how to do it. What I'm going to show you though is, I'm going to assume that they've already done this pairing for us. They've chose 8 people out of the 24, and I'm going to do the second part to C again in this new way, because it's actually an interesting answer as well. But I warn you that I'll talk more in a moment. I warn you, I think whatever this number is should be involved in it as well. Okay, so here's what I think D is asking us. It's like C part 2 again. We have a group of 8 people and they're going to choose 2 people out of a group of 16 people. How does that look? The first person is going to come along and choose one person. They're going to choose 2 people out of that group of 16. So that's going to look like this: 16 choose 2. So this is the same notation, C notation or the bracket notation. So that first person is going to choose this. I'm not sure what that number is. It's probably 40 or 50 something, quite big number already. But the second person is going to come along then, and they're going to pick 2 people, but there won't be 16 to pick from. There'll only be 14 to pick from. The next person will come along and there'll only be 12 to pick from, and this will stay happening all the way down. 6 choose 2, 4 choose 2, 2 choose 2. This is a pretty big number. I think this might be the number they're looking for. I think this is the answer they're looking for. You can put all this onto a calculator. It'll take you a while. I'll show you a little trick now in a moment. But you can put all that into a calculator and you get the impressively big number of, is that 80 trillion, I think. But in scientific notation, like they asked for, it's 8.173 times 10 to the power of 10. How many decimal places? 3 decimal places. Okay. That's I believe the answer to the question. But I do think that would leave out lots of combinations of pairs if we broke the group up into another way. And I don't think they told us they did the breaking up for us. So honestly, I don't know how to answer the question past that. You let me know if I've made a mistake. You let me know if you think this is the full answer. Oh yeah, let me explain more how to do this without a calculator. You need a calculator a little, but the choose notation, we can break that up. That's 16 factorial divided by 2 factorial, 14 factorial. That's what 16 choose 2 looks like. This one is 14 factorial, 2 factorial, and 12 factorial. It's 14 minus 2 gets that 12. This one is 12. I'll leave out factorial for now just to save my writing. 2 and 10. This one would be 6, 2 and 4. This would be 4, 2 and 2. And this would be 2, 2 and 0. 0 factorial. These are all factorials. Multiply all these together. You can actually cancel a 14 cancels 14. 12 cancels 12. This 10 would cancel with an unwritten 10 here, and so on all the way down. This 6 would cancel with an unwritten one there. This 4 with this 4. This 2 with this 2. All we're left with on the top row is 16 factorial, and all we have in the bottom row is 2 factorial. Is just 2. Is 2, and there is, how many of them is there? There's 8 of them. Be careful adding them up though. I have to double check that one. And you put all that into a calculator, you should get the same number up here. 8.173 times 10 to the power of 10. Okay, that's it for question 9. I hope, I'm not even sure I got the right answer in the last part. So if you have any follow-up questions or any comments, let me know in the comments below. Do me a favour and put a timestamp in, and I'll do my best to get back to you. Thanks for watching. Have a great day.